Hello everyone, this is Sagrika from Campus Technology, a portfolio company of Times Internet. So, as you can see on your screen, today we'll be talking about biometrics. We have all heard this term, but in today's video, we'll understand what is biometrics and how it can be a useful boon to our society. Before beginning, we have to understand the meaning of biometrics. Biometrics was once something confined to the world of science fiction, but over the past decade, we have seen the emergence of biometrics in our everyday lives. Biometric technology has evolved rapidly in the recent years. Now, it's a rare day when we don't interact with some form of biometric technology, from unlocking your phone to finding out the weather for the day to securely boarding a flight. Biometric technology is all around us. Fingerprint recognition was one of the first biometric technologies to be widely adopted. But now we are seeing the integration of the facial recognition, voice recognition, and iris recognition into the day to day interactions. To go by a firm definition of biometrics is the measurement and analysis of someone's unique physical and behavioral characteristics. This technology is used for identification and authentication. Identification refers to figuring out who the person is, and authentication, as in someone who they say they are, and to verify that. For someone to prove their identity, they need to possess something specific, like a card, badge, or key card, know something specific, like a name or password, and use something specific on their body, like the fingerprint, face, or eyes. There is no denying that biometrics seems complicated, but in reality, all biometric systems can use simple steps, and they are three in number. Firstly, enrollment, then storage, and comparison. The first step used in biometrics is enrollment, where it records the basic information about you. This could be your name or an identification number. It will then capture an image or record a specific trait. Then we have storage. Instead of storing the complete image or recording, the trait that was recorded is analyzed and translated into a line of code or a graph. Lastly, comparison. The next time you encounter a system, it compares the trait you present to the information it has stored on the file. The system will then either accept or reject whom you claim to be. Three important components of biometric includes a sensor which detects the characteristics used for identification, a computer that reads and then stores this information, and a software that analyzes the characteristic, converts it into a graph or a line of code, and begins the actual comparisons. On your screen, you can now see the various types of biometrics we have around us. Biometrics isn't a one size fits all type of technology. There are many ways biometrics is usually used to identify if a person is real, who they claim to be, or if they are just lying. A biometric identifier typically falls into two categories: physical identifiers and behavioral identifiers. Physical identifiers are limited to certain fixed set of characteristics, while the behavioral ones have limits in human imagination. Both can be used to distinguish between a human and a robot. Some common examples of the behavioral characteristics would be typing patterns, physical movements, and navigational patterns. On your screen, you can see some of the most used physical identifiers. First one is facial recognition. In facial recognition, there's a software which is used to map an individual's facial features and then store the data of these features. A facial recognition system will use biometrics to map the face and compare it with a database to find a proper match. Using the face detection, face capture, and face match, this technology analyzes over 80 elements of the human face. Next, fingerprints. This is yet another popular type of biometrics which is used in the common terms. An obvious example of this is the phone which you use, and a lot of phones today have the finger authentication program available. Fingerprints are typically used to authenticate someone rather than identifying someone. Next, we have iris detection. In iris detection, we use a digital camera, visible light, and near infrared light. With the eyes between 3 to 10 inches from the camera, the computer works to locate the center of the pupil, the edge of the iris, the edge of the pupil, the eyelids, and the eyelashes. The pattern of the iris is then translated into a line of code. Iris scanning is becoming increasingly popular in the security realm, as the chance of mistaking one iris code for another is 1 in 10 to the 78th power. So almost nil. There are almost over 200 points of references as opposed to the 60 to 70 in fingerprints. Next, voice recognition. Voice recognition, otherwise also known as voice prints, is unique in the sense that your vocal cavities create a specific shape when your mouth moves to speak. For this to work, you would need to say an exact word or phrase that the system requires, or give an extended sample of your speech so that it can recognize you no matter what you're saying. The data used in voice print is also called as sound spectrogram, which is essentially a graph that shows the sound frequency. Different speech sounds will create different shapes on the graph. These graphs also use colors or shades of gray to represent the quality of the sound of a voice. Next, DNA scanning, which is the identification of someone using the analysis of specific segments from their DNA. This can be anything from a hair follicle to a drop of blood. DNA scanning is an up and coming type of biometrics and is used primarily in law enforcement to identify suspects. It is also the only biometric process that can link person to their relatives, providing specific information about a person. Another major perk, the results of a DNA test can be available in as little as merely 90 minutes. Next, we have handwriting. I know what you're thinking. How can a simple handwriting determine who the person is? After all, a lot of us have forged our parents' signatures. But handwriting is a different type of technology altogether. When analyzing the handwriting, biometric systems don't examine the shape of each letter, but rather the act of writing. Things like the pressure you use, the speed, and the rhythm of how someone writes. Also recorded in the sequence is in which letters are formed, like if you dot your I's and cross your T's as you go, or after you finish the entire word. This means that even if someone got a copy of your signature, the system wouldn't accept their forgery and would know that it's not the real you. Lastly, vein recognition. Like your iris or fingerprints, your veins are unique. So much so that not even twins have the identical veins. The shapes also changes very little as we age. To use a vein recognition system, you would place your finger, wrist, or the palm or the back of your hand on a scanner. A digital camera would then take a picture using the near infrared light. The hemoglobin we have in our veins will appear black in the photo, and the software will create a template based on the shape and location of the structure of your veins. You can now see the common places or applications of biometrics, usually seen in the airport security, law enforcement, banking, mobile access and authentication, building access, the schools, and lastly, public transports. Now, we have some of the common characteristics of biometrics. Firstly, universality, which means that every person using a system should possess that trait. Next, uniqueness, which means the trait should be significantly different for individuals in the relevant population such that they can distinguish one from another. Thirdly, permanence, which relates to the manner in which a trait varies over time. More specifically, a trait with good permanence will be reasonably invariant over time with respect to the specific matching algorithm. Then we have measurability, which relates to the ease of acquisition or measurement to the trait. In addition, acquired data should be in a form that permits subsequent processing and extraction of the relevant feature sets. Next, performance, which relates to the accuracy, speed, and robustness of technology. Then we have acceptability, which relates to how well individuals in the relevant population accept the technology such that they are willing to have their biometric trial captured and assessed. Lastly, circumvention, which relates to the ease with which a trait might be imitated using an artifact or substitute. Now it's time to know what is multimodal biometric system. Well, a multimodal biometric system uses multiple sensors or biometrics to overcome the limitations of unimodal biometric system. For instance, iris recognition systems can be composed by aging irises, and electronic fingerprint recognition can be worsened by worn out or cut fingerprints. While unimodal biometric systems are limited by the integrity of their identifier, it is unlikely that several unimodal systems will suffer from identical limitations. Multimodal biometric systems can obtain sets of information from the same marker or information from different biometrics such as fingerprint scans and voice recognition. Multimodal biometric systems can fuse these unimodal systems sequentially, simultaneously, a combination thereof, or in series, which refers to sequential parallel, hierarchical, and serial integration modes, respectively. I hope you all like this video and could understand the meaning of biometrics, the various uses of biometric, application of biometrics in everyday life, and the science behind biometrics. Thank you.